Hello, class. Today we're going to cover Math 131, Objective 13. For Objective 13, we are going to solve quadratic equations by taking square roots, okay? So the first thing we need to know, if x is a variable that can be positive or negative, then the square root of x squared equals the absolute value of x, okay? And with the absolute value, if you don't remember what that is, basically whatever is inside of it, when it comes out, it will be positive. So it could be something that's positive or negative inside of those absolute values, but it will come out positive, okay? So this fact can be used to solve a quadratic equation by taking square roots. So for this first example, we want to solve x squared equals 9 by taking square roots. So we want to think if x squared equals 9, okay? The way that we solve equations before, we kind of work backwards to figure out what x equals. So if we want to break down x squared, we can do the opposite of squaring something, which is take the square root of it, okay? And of course, if we do it on one side of the equation, we'll have to do it on the other side. So we will take the square root of both sides, okay? So what taking the square root of x squared is going to do is going to give us the absolute value of x, okay? So before this point, if we were asked what the square root of 9 was, we would probably just say 3, okay? But now that we are introducing this fact, we need to know that when we take the square root of 9, because of how this absolute value works, the solution of the absolute value equals 3. What it means is that x is -3 and 3, okay? So therefore, the solution of x squared equals 9, they are plus and minus 3, okay? So the same way we had those two values for x, we're still going to have two values for x here. And in this particular problem, it's plus and minus 3, not just 3, okay? So from this moment forward, when you are asked the square root of something, it's probably going to be plus or minus whatever that number is. Okay, so let's get into some more examples. All right, so let's continue looking at our examples. For example 1, we're going to look at 3x squared equals 48. All right, 3x squared equals 48. So in order to solve this, okay, remember we're solving by taking square roots. For this particular problem, we can't just jump in and take the square root right away, okay? We need to first tackle that 3, okay? So the 3 is being multiplied by the x squared. So with these problems, we want to try to get whatever is being squared, we want to get that part by itself. So first we need to divide everything by 3 to get rid of that 3. We're going to have x squared equals, and 48 divided by 3 is going to be 16, okay? Now that we have something squared, we can take the square root of both sides like that, okay? And so the square root of x squared, that is going to be x, and the square root of 16 is going to be plus and minus 4, okay? So it's not going to just be 4, all right? It's going to be plus and minus 4, which means we have two x's. We have positive 4 and negative 4, okay? So on your paper, you can write plus and minus 4, or you can write 4 and negative 4, okay? Either way, it needs to be negative 4 and positive 4, or positive 4 and negative 4. All right, let's look at another one. We got, for example, 2. We got 2x squared minus 8 equals 0. 2x squared minus 8 equals 0, okay? So y'all know how we do it. The problems get a little bit more complicated as we go. But I want you all to remember our goal. We want to try to get that x squared by itself, the same way in the past when we were solving equations, we were trying to get the x by itself. For this, we're just trying to get the x squared or whatever squared by itself. So that means that we need to move this 2 here and this negative 8 here, okay? First, we're going to have to move this negative 8. This negative 8 is being subtracted, so we're going to have to add 8 to both sides. So we're going to have 2x squared equals 8, okay? Now, we still want to get the x squared by itself. So now we can tackle the 2, all right? Since the 2 is being multiplied by the x squared, we can divide both sides by 2 to get rid of that. And we'll have x squared equals, and 8 divided by 2 is going to give us 4, all right? Now that we have x squared equals 4, now we can take the square root of both sides. Okay? So the square root of x squared is going to be x, and the square root of 4, remember, from this point forward, is not going to just be 2, is going to be plus and minus 2. Okay? So hopefully that makes sense to everybody. All right. So now let's get into more examples. Want to make sure you all got it. All right, example 3. We got r squared minus 36 equals 0. For example 4, we got s squared minus 4 equals 0. And for example 5, we got y squared equals 49. All right. So these problems are pretty simple. We're going to start out with some simple ones to make sure everybody understands, okay? So the goal, we want to make sure we isolate whatever is being squared, okay? So in example 3, it's the r squared. So we want to move this negative 36 by adding 36 to both sides. Okay? And we'll have r squared equals 36. Now that we have that r squared by itself equals something else, now we can square both sides. Okay? R squared, no, the square root of r squared is going to be r, and the square root of 36 is going to be plus and minus 6. Okay? For example, 4, we have s squared minus 4 equals 0. We want to isolate or get the s squared by itself. So we're going to add 4 to both sides. And we have s squared equals 4. Now that we have that s squared by itself, we can take the square root of both sides, okay? The square root of s squared is going to be s, and the square root of 4 is going to be, everybody should be saying it out loud or writing it on your paper. We all know what it is. It's plus and minus 2. And for example 5, we have y squared equals 49. All right. The y squared part is already by itself. So that means that we can go ahead and take the square root of both sides. All right. And even when we are at this point, you all, I want you to rewrite it and then take the square root. Okay. So don't just come in up here in the original and put the square root. I want you to rewrite it and then take the square root so you can see what happened from here to here, okay? So the square root of y squared is y, and the square root of 49 is plus and minus 7, okay? So hopefully, when the problem is set up this way, you all understand what to do. Now let's look at some different problems, okay? We're going to take it up another notch, all right? So for these problems, we got a little some different we got to do. So for example 6, we're going to solve by taking the square roots, which is what we already been doing. But for this problem, we got x minus 1 squared equals 36. X minus 1 squared equals 36. Okay? So remember, our goal is to have whatever squared over here and then equals something, okay? So this problem is set up for us to just go right in and take the square root. So remember, I said I wanted you all to rewrite it and then take the square root of both sides, okay? So when we take the square root of x minus 1 squared, remember the square root basically cancels out the squared part. So what's going to be left is x minus 1. I need everybody to make sure they got that, okay? Now, when we come over here to take the square root of 36, that is going to be plus and minus 6, okay? So since we have the x minus 1 equals plus and minus 6, we have to break this into 2 separate problems so that we can figure out what our 2 x's are. So over here, I'm going to work x minus 1 equals 6. And over here, I'm going to work x minus 1 equals negative 6, okay? So for the first one, we will add, I need to add 1 to both sides. So x will be 7. And for this one, when we add 1 to both sides, x will be negative 5. So we still found our 2 x's, okay? X is 7 and x is negative 5, all right? So these are a little different than the problems we just looked at, okay? Let's look at another one. We got, for example, 7. We got 4 times s minus 2 squared equals 36, okay? 4 times s minus 2 squared equals 36, okay? So remember, we want to get the part of the problem that has something squared. We want to get that by itself. So this part we want by itself, that s minus 2 squared. So this 4 out in front that's being multiplied, we're going to have to divide both sides by 4. So when we do that, we're going to be left with s minus 2 squared equals, and 36 divided by 4 is going to give us 9, okay? So now that we have something squared equals something else, all right? Preferably the something else, we want it to be a perfect square, okay? And 9 is a perfect square. So now we can take the square root of both sides. So I'm gonna rewrite it and then take the square root of both sides. So when I take the square root of s minus 2 squared, what that is going to do is give me the s minus 2. That is going to come out. And then the square root of 9 is going to be plus and minus 3, okay? So that means I'm going to have to break this up into two problems. S minus 2 equals 3, and S minus 2 equals negative 3, okay? I'm going to have to add 2 to both sides. And so one of my S's is going to be 5, the 3 plus the 2. And my other S, the negative 3 plus 2, is going to be negative 1. All right. I hope it's making sense. Okay. All right, let's do a couple more. Since this is a video, I'm going to make sure I get all of the examples on here for y'all. All right. So for example, 8, we have 5 times z plus 2 squared equals 125. All right. Again, we want this part by itself, the z plus 2 squared. So we're going to have to divide both sides by 5. That is going to leave us with z plus 2 squared equals, and 125 divided by 5 is going to be 25, okay? Now that we have something squared equals a perfect square, we can take the square root of both sides. So when we take the square root of z plus 2 squared, z plus 2 is going to come out, and the square root of 25 is going to be plus or minus 5. Y'all should know the routine by now. We're going to set up two problems. Z plus 2 equals 5. And we're going to subtract 2 from both sides to get z equals 3. And for our other problem, we're going to have z plus 2 equals negative 5. We're going to subtract 2 on both sides. And z is going to be negative 7. All right. So z is 3 and negative 7. All right. We got 2 more examples. For example, 9, we have 2 times y minus 3 squared equals 18. So by this time, you should know that y minus 3 squared is what we want to leave over here. So this 2 has got to go. So we're going to divide both sides by 2, which is going to leave us with y minus 3 squared equals 9. At this point, we have something squared equals a perfect square. That lets us know that now is the perfect time to take the square root of both sides, okay? When we take the square root of something squared, that something is now going to come out. So we have y minus 3 equals, and the square root of 9 is plus and minus 3. Now we got to set up our two problems. We got y minus 3 equals 3, and y minus 3 equals negative 3. So for both situations, we're going to add 3 on both sides. And our first y is going to be 6, and our second y is going to be 0. Okay? Hope that makes sense. And for our last example, we're going to add one more little variation, okay? So for this one, we have 2 times x plus 1 squared minus 32 equals 0, okay? So for this problem, we're going to have to move the 2 and the negative 32. So we will start by adding 32 to both sides. We'll have 2 times x plus 1 squared equals 32. From here, we will divide both sides by 2. And we'll have x plus 1 squared equals 16. Now, hopefully you know what's next. We are going to take the square root of both sides. When we do, x plus 1 is going to come out, and the square root of 16 is going to be plus or minus 4. So when we break this into our two problems, we're going to have x plus 1 equals 4, and x plus 1 equals negative 4. So we're going to have to subtract 1 on both sides. And our first x is going to be 3. And our second x is going to be negative 5. All right. So that completes objective 13. With this, you are able to complete the homework and everything else that you need to do. All right. Have a great day.